Welcome to this explainer. Today we're diving deep into Marvin Minsky's foundational contributions to artificial intelligence and really analytically exploring how his ideas fundamentally reshaped the entire field. We are going to look way beyond the typical, oversimplified narratives you might have heard and dig right into the core concepts that defined his incredible legacy.
Okay, let's quickly map out where we're headed today. We'll start with the promise of early AI, then hit the XOR wall, examine the deeper structural problem, introduce frames and contextual knowledge, explore the society of mind, and finally, bridge those AI paradigms.
Section 1. The Promise of Early AI and the Dawn of Neural Networks. Let's head back to the very beginning to understand the initial explosive excitement around connectionist models.
Now, a lot of people don't realize this, but Minsky himself was absolutely a pioneer of early neural networks. Long before the heated debates of the 1960s, a young Marvin Minsky actually built the Snark machine back in 1951. Imagine this. To simulate a single rat learning a maze, he had to wrangle something like 300 glowing vacuum tubes and mechanical motors. So right from the start, he was deeply personally invested in this bottom-up connectionist approach.
Then, jump to 1958. Frank Rosenblatt introduces the perceptron. This was a single-layer model that researchers genuinely believed could learn, recognize patterns, and eventually just lead straight to true human-level AI. And honestly, it was an incredibly seductive idea. The thought was that you had this homogeneous system. You just feed data into it, and it automatically learns to map inputs to outputs by adjusting its weights. The optimism back then was just sky high.
Section 2. Hitting the XOR wall and the limits of homogeneous AI. Because as we're about to see, this early programming approach hits some very strict, undeniable mathematical limits.
The fundamental issue they ran into wasn't that perceptrons couldn't learn at all. It was that these single-layer models could only solve what we call linearly separable problems. Think of a simple AND or OR logic gate. You can literally draw a single straight line on a graph to separate the true outputs from the false ones. It's clean. But real-world intelligence, that requires solving non-linearly separable problems. And for those, a single straight line just is not going to cut it.
Minsky and Papert proved this definitively in their 1969 book, Perceptrons. When you map out the XOR function, it mathematically proves that a single-layer perceptron simply cannot draw a straight line to separate those data points. There is no single decision boundary. And the crucial thing to understand here is that this wasn't just, Minsky's opinion. It was a rigorous, mathematically undeniable limitation of that specific architecture.
Now, Minsky is very often blamed for triggering the first AI winter because of this. But the truth is, he wasn't anti-neural network at all. He was simply advocating for realistic expectations, especially regarding convergence time and structural limits. He was essentially warning the field, saying, look, simply scaling up a single-layer perceptron isn't going to magically yield human intelligence. It was a call for the architecture to evolve, absolutely not a demand to just abandon the research entirely.
Section 3. The deeper structural problem. Moving beyond a single equation. And this really brings us to the core of Minsky's philosophical pivot.
He realized that AI researchers were making this massive mistake. They were treating AI like physics. They were desperately searching for this one, simple, compact mathematical law that would magically explain all of human thought. But in biology, and certainly in the human brain, there is no single Maxwell's equation for intelligence. Real intelligence is messy, it's highly evolved, and above all, it's incredibly diverse.
Minsky identified a pretty severe rift happening in the field. On one side, you had symbolic systems. These were way too rigid. They relied on strict top-down logic and just completely broke down when faced with fuzzy exceptions or the messiness of the real world. On the flip side, you had the connectionist systems, the bottom-up neural nets. These were crippled by a total lack of structural architecture. They were basically blank slates, and treating them as universal, unstructured solvers was, in Minsky's eyes, a dead end. So the takeaway here is that both of these extreme approaches fundamentally failed to scale. Symbolic AI breaks down the second it hits ambiguity, while connectionist AI just turns into an opaque, tangled mess as you grow it. Minsky saw, clearer than anyone, that we desperately needed to integrate these systems. They fail on their own because human thinking relies on pulling together multiple, entirely different systems, not just relying on one trick.
Section 4. Frames and contextual knowledge. To actually solve this huge representation problem, Minsky proposed some brilliant new frameworks.
Let's jump to 1974. Minsky publishes this truly foundational paper that shifts AI away from using these isolated, brittle fragments of logic.
He wanted to solve a very specific mystery. How do humans so instantly grasp the context of a new situation without having to calculate every single tiny detail from absolute scratch?
His answer was something he called a frame. Think of a frame as a way to package up your expectations. Like when you walk into a kid's birthday party, you don't have to deduce what's happening from zero. You inherently know there's going to be a cake, presents, probably some chaos. Minsky realized that a machine needs these exact same pre-packaged, stereotyped structures if it's ever going to function efficiently in the real world.
By establishing context this way, frames drastically reduced the massive search space that was completely paralyzing early AI systems. It works like this. You encounter a situation, you pull up the relevant frame, and then you just fill in the specific slots with what you actually see. So, you replace the generic host with your friend John, and for anything you don't immediately see, you just use default values. It is a wonderfully elegant architecture for common sense.
Section 5. The Society of Mind and Intelligence as an Emergent Property. Building on this whole idea of structured knowledge, Minsky decided to scale his vision all the way up to the entire human brain.
This led to his famous Society of Mind theory, where he argued that intelligence is fundamentally emergent. You don't just have this single glowing orb of intelligence sitting in your head. Instead, you have a massive, bustling society of tiny, incredibly simple processes that all work together to create the grand illusion of a unified mind.
So forget the idea of one universal learning algorithm. The mind is a society of specialized interacting agents that have been evolving for millions of years. You've got an agent for recognizing an edge, an agent for understanding gravity, an agent for balancing your weight. Isolated, they literally know nothing, but together, they constantly exploit each other's outputs so you can walk, talk, and think without even trying.
Because he understood the absolute necessity of this complex underlying architecture, Minsky accurately foresaw the total collapse of those specialized, brittle expert systems in the late 1980s. The industry was just pouring billions of dollars into these highly specialized logic programs. But Minsky knew that without a diverse society of common-sense agents to support them underneath, those systems would eventually hit a wall and shatter. And as history shows us, he hit the nail right on the head.
Section 6. Bridging the AI Paradigms.
Finally, let's look at what Minsky believed was the true, ultimate solution for building artificial intelligence.
He strongly urged the field to stop asking whether the top-down or the bottom-up approach was the best one. Instead, he wanted us to focus on building bridges to combine their respective strengths. A concept that is totally isolated in a single neural net or stuck in a single logic tree is incredibly fragile. True, robust meaning only comes from the interconnectedness of many different representations.
True intelligence, as Minsky taught us, requires the flexibility to view a single problem from 20 or 30 completely different perspectives, driven by diverse architectures. If an AI gets stuck using a logical approach, it has to be able to just seamlessly switch gears to an analogical or a connectionist approach. That administrative oversight, that built-in diversity of thought, is absolutely the key to the whole shebang. So as you consider the massive neural networks dominating the news today, I want you to ask yourself a question. Have we actually embraced Minsky's call for architectural diversity, or are we just repeating the history of the single algorithm all over again? Are we just building bigger, more expensive perceptrons, or are we truly engineering a resilient society of minds? Definitely something to think about as you watch this incredible field continue to evolve. Thank you so much for joining me on this explainer. I really hope this helps structure your understanding of one of AI's greatest pioneers.